Hello everyone, welcome back to AH Academy. In this week's video, we'll be looking at the second section of the CXC January 2020 Paper 2. And if you haven't seen the previous video, then please have a look at the channel. It's the last video that was uploaded. If you have any questions or need any clarifications, then please leave them in the comment section below and I will try to get back to as much of you as possible. For those of you that are new to this channel, please be sure to subscribe below and hit that like button, and also remember to share this video with a friend. Section 2, question 8a. Solve the pair of simultaneous equations. We have y squared plus 2y plus 11 is equal to x. And we have x is equal to 5 minus 3y. To solve the pair of simultaneous equation here, we can use the method of substitution. Since we have one equation equal to x and then we have x is equal to another equation, so we can substitute the value of x here into this equation and then we can solve this simultaneously. So we have y squared plus 2y plus 11 is equal to x, but we're going to put our value for x here, substitute this value of x into here. So we have 11 plus 11 is equal to 5 minus 3y. Now we're going to try to make this into one equation. So we're going to have y squared plus 2y plus 11. Since we're trying to move this 5 or bring it onto the left hand side of our equation, we're going to subtract it. So it's going to cancel here and it's going to be subtracted on this side of our equation. So we're going to have minus 5 is equal to minus 3y. And once again, we're trying to bring our negative 3y over the equal sign or on the left hand side of our equation. So therefore, we're going to add 3y, which is we're just going to cancel it on our right hand side and it's going to be added to this side of our equation. So, okay, we minus 5 here and then we're going to be adding 3y. Yeah, so we now have y squared plus 2y plus 11 minus 5. We can simplify that to 6 plus 3y is equal to 0. And we can simplify here 2y and 3y. So we now have y squared plus 5y plus 6 is equal to 0. We now have a quadratic equation and we can find our 2y values and then we can substitute those 2y values to find our x values. We can use the AC method once again. For a shorter method, we can actually look at our equation. We know that the two numbers that we're going to find to substitute for our b value has to be added or subtracted. Those factors of our AC, which is going to be 6, because 6 times 1 is 6. Those two numbers will have to be added or subtracted to give us our b value. And looking at this, I can already tell our answer is going to be y plus 3 and y plus 2. Because 2 multiplied by 3 gives us 6, and 3 plus 2, 3y plus 2y would give us 5y. But using the AC method, let's confirm this. So AC is equal to 6 times 1, which is 1 times 6 is equal to 6. So that's our AC, and two numbers that multiply or our factors of 6 is going to be 1 and 6, 2 and 3. And we need to find a number that's when added or subtracted is going to give us a positive 5. And that is the only two factors that can do that is 3 and 2, because 6 minus 5, 6 minus 1 is going to give us 5. And 2 and 3 are the only numbers that can give us that value, because 6 minus 1, 6 take away 1 would give us a positive 5, but 6 multiplied, a positive 6 multiplied by a negative 1 is going to give us a negative 6, which is not what we want. We want a positive 6. So 3 plus 2 is going to give us a positive 5, and 3 times a positive 2. So that's a positive 3 and a positive 2. So 3 plus 2, positive 5, and 3 times 2, positive 3 times positive 2 is going to give us a positive 6. So those are our two factors. So it's y plus 3 and y plus 2. Now to find our values of y, we just equate this to 0 and equate this to 0 as well. So y plus 3 is equal to 0. And then we have y plus 2 is equal to 0 as well. To find our y value, we make y the subject of the formula. So it's going to be y. And to cancel our 3, we need to take it away. So it's going to be y is equal to negative 3. And then once again here, to find our value for y, we're going to take away 2. So it's going to be y is equal to minus 2. Now to find our x values, we need to substitute our y values into one of our equation, and I would choose our first equation here, or second equation here, because that is the easier option. So we have x is equal to 5 minus 3y. We know our value for y is negative 3, so x is equal to 5 minus 3 times negative 3. So x is equal to negative 3 multiplied by negative 3 is going to give us a positive 9. So 5 plus 9 is going to give us 14. And then we have x is equal to 5 minus 3y once again. X is equal to 5 minus 3 times negative 2. X is equal to negative 3 times negative 2 is going to give us a positive 6. 6 plus 5 is going to give us 11. So our answer is y is equal to negative 3. When y is equal to negative 3, x is equal to 14. And then when y is equal to negative 2, we have x is equal to 11. And we can check if our answer is correct by substituting this value into our equations here, our first equation. So let's just test that out quickly. So for using our first equation, if we have use y as negative 3, so negative 3 squared plus 2 times y, which is negative 3. Oops. Negative 3 plus 11, we should have our x value, which is 14. And then once again, using our second y value, which is negative 2, we have negative 2 squared plus 2 times negative 2 plus 11 is going to give us 11, which is our second x value. Yeah, so that's how we check our answers, and therefore our answer is correct. Part B. The function f is defined as follows. F of x is equal to 4x squared minus 8x minus 2. Express f of x in the form a brackets x plus h squared plus k, where a, h, and k are constants. By looking at this, we know this is completing the square. We have to use completing of the square. There are two identities that we should know or at least try to remember when it comes to completing the square. One, which is x squared plus 2bx plus c is equal to x plus b squared minus b squared plus c. And then our second identity is x squared minus x squared minus 2bx plus c is equal to x minus b squared plus c. So this is just a guideline on how you get your quadratic equation in completing the square form. Back to our question. We need to express our quadratic equation into the form ax plus h squared plus k. Our equation is 4x squared minus 8x minus 2. First things first, as we can tell, we need to get rid of our 4. That's the first thing. We need to get rid of this x, the constant in front of x, which is 4. Doing that, we're going to divide everything by 4 to get rid of the 4. So we're going to put our 4 outside of the brackets because we are dividing everything by 4. That gives us x squared. This looks like a plus. So x squared minus 2x, sorry. And then half. That is equal to 0. So this is our new equation, x squared minus 2x minus half. Now we need to sort this out. We need to convert this or express this in this format. What we're going to do, we're going to still put our 4 here. We're not dismissing it. It's just there, but we're not going to be using it right now. We're going to put our brackets. So now if we're trying to express this in the form of this, according to our identities that we've listed above, what we need to do is write our x. We're going to have x. We're using our second identity. We're going to have x minus b. Our b value here is 2, but our x value here, our minus value here, is going to be half of b, which is minus 1 squared. So we're halving the b value here. Half of 2 is 1. Then continuing, it's going to be minus b squared. So our b value, which is minus 1, minus 1 squared is still minus 1. Yeah? And then we're going to add our c value, which is minus half. So our c value is going to be minus half. We write in that. We're going to have x minus 1 squared minus 1 minus half, minus 1 minus half. And then we can simplify that again. And we're going to have 4 x minus 1 squared minus 1 minus half is going to equal to minus 3 over 2. And what we need to do now, we're going to multiply our 4 by everything inside of our double brackets, our squared brackets. So 4 multiplied by x minus 1, we're going to have 4x minus 1 squared. And then 4 multiplied by negative 3 over 2 would give us a negative 6 value. And that is our equation expressed in this form. And we're going to have our a value, our h value, and our k value. We're now asked to state the minimum value of f of x And to find our f of x minimum value, it's going to be our k value. And from what we've just worked out here, our k value is -6. So that is our minimum value. And then we're asked to determine the equation of axis of symmetry. And the equation of the axis of symmetry is going to be our value of h, which is 1. Oops. Yeah, our axis of symmetry, when they ask you for the axis of symmetry, that's our value here, our h value. And in this case, it was 1. C. The speed-time graph below, now drawn to scale, shows the 3-stage journey of a car over a period of 40 seconds. We have our graph, and we're asked to determine the acceleration of the car for each of the following stages of the journey. Stage 2, which is here. By looking at this, we can tell that our acceleration would be 0 because we're just stagnant. We're moving in time, but we're not moving in speed. So to find our acceleration, using a formula, we're going to have acceleration is equal to our change in velocity divided by our change in time. That's our formula for velocity. And that's going to be our final velocity minus our initial velocity divided by our final time minus our initial time. Final velocity. So for stage 2, our final velocity is going to be 12 minus our initial velocity, 12 again. And then our time final, which is 32, minus our initial time, which is 16. 12 from 12 gives us 0, 32 from 16 gives us 16, 0 divided by 16, sorry, is equal to 0 because any number divided or multiplied by 0 is equal to 0. Stage 3. This is stage 3. Once again, our acceleration is equal to v final minus v initial divided by final time minus initial time. Our final velocity, so this is stage 3, so our final velocity is going to be 0. That's our end here, so final velocity is equal to 0. Subtract our initial velocity, which is here, 12, divided by our final time, which is 40, minus our initial time, which is 32. 0 minus 12 is going to give us a negative 12 divided by 40 minus 40 subtract 32, which gives us 8. And simplifying this, we're going to have negative 1.5 as our answer, and that is going to be meters per second or meters per second squared. And our value is negative because, as we can tell, we are decelerating. So we're slowing down instead of speeding up. So that's why we have a negative acceleration value. So our answer is negative 1.5 meters per second. And just to note how we got our unit, 12 is our speed. Our units for 12 is meters per second, and that is divided by our units, which is 8, and 8 is our time, which is second. And converting this, we're going to have m over s multiplied by, remember s is over 1 here, so it's going to be 1 over s and that is going to be m over s over m over s squared, because that's s and s. Sorry, no negative there. Yeah, which is meters per second squared. If we wanted to write it the other way around, it would be meters second to the power of -2. Question 9. The circle shown below has center 0 and points A, B, C, and D lying on the circumference. A straight line passes through the points A, B. Angle CBD is equal to 90 degrees and angle OAB is equal to 37 degrees. Write down the mathematical names of the straight lines BC and OA. BC, we know that's a chord. And OA, point from the center of the circle to a point on the circle, that's a radius. 2 marks. Part 2. Determine the value of each of the following angles. Show detailed working where necessary and give a reason to support your answer. Okay, we need to find for x, which is here. Looking at our circle, we know this is a radius, OA is a radius, and OB is also a radius. So if OB is a radius, and we know the angle OAB is 37, then we can find this angle. Reason being, we have 2 equal lengths, therefore we're going to have 2 equal angles, and that is because this is going to be an isosceles triangle where we have 2 equal angles, opposite lengths are also equal. Yeah? So if this is 37 degrees, then this is 37 degrees. And if we know 2 angles in a triangle, then we can easily find the third angle because we know the total angles in a triangle is equal to 180 degrees. Yeah? So let's do our calculation. We have 180 degrees, which is the total angle in a triangle, minus our 37 degree plus the other 37 degree, which is going to give us 37 plus 37 is going to give us 7 and 7 is 14, 3 and 3 is 6, plus 1, 74 degrees, and then we're going to have 180 degrees minus 7 and 74 degrees is going to give us 106 degrees. 180 degrees minus 74 degrees gives us 106 degrees, which is our angle X. So here is equal to 106 degrees. Reason, we can say that angle OAB is an isosceles. Why do I keep missing my E? Isosceles triangle hence we have opposite angles are the same, and opposite lengths as well. which is the radius we're speaking about, and total angle. In triangle is 180 degrees. Yeah, somewhere, some area along here, some reasoning along here would give you 2 marks. B, they're asking us to find the angle Y, which is here. Looking at our circle shown, we know that one of our circle theorems is the angles in a semicircle is equal to 90 degrees. Looking here, we have a diameter, therefore we have a semicircle here. Yeah, we have 2 semicircles here and here. But in this semicircle here, we have an angle. And according to our theorem, this angle is going to be 90 degrees. So now that we know 2 of the angles, we can find the third angle. Yeah. So it's going to be 180 degrees subtract 90 degrees plus 49 degrees. So 180 degrees minus 9 and 0 is 9, and 9 plus 4 is going to give us 139, sorry. And then we're going to have 180 minus 139. Why do I keep rewriting it? It's just too late to turn back, so I'm going to keep writing it. 180 minus 139 degrees is going to give us an answer of 41. There's my calculator. So let's check this. 90 plus 49, 139. And then we're going to have 180 minus 139 gives us 41 degrees. Our reasoning, similarly to what we said before, angle in a semicircle. Is 90 degrees, and that is actually angle BCD. And we also have angles in a triangle equal to 180 degrees. Yeah. Any reasoning along these lines will give you your 2 marks. B, the diagram below now drawn to scale shows the route of a ship cruising from Palm City P to Quaytown Q and then to Riverton R. The bearing Q from P is 133 degrees and the angle PQR is 56 degrees. Calculate the angle W. Okay. From what we know about bearing, they tell us that the bearing of Q from P is 130 degrees. From here to here, we know that these 2 angles must add up to 180 degrees. This is where our angles concerning coordinate, alternate, that's our Z, F, U, or C, whichever one you use. These angles, that's where it comes into play. And using our U or C, these 2 angles need to equal to 180 degrees. So using our calculator, 180 minus 133, this angle here is going to be 47 degrees. And Since this is a straight line, this is our north line, this is one straight line, and we know the angles on a straight line is equal to 180 degrees. So we know two of our angles, and if we're to subtract those two angles from 180 degrees, we're going to have our value for W. So we're going to have W is equal to 180 degrees subtract 47 plus 56, and that's going to equal to 180 subtract 47 plus 56 is going to give us 3, and then 5 and 4 is going to be 9 plus 1. 103 subtracting 180 from 103 is going to give us 77 degrees. So our W value is 77 degrees. Moving on. We're asked to determine the bearing of P from Q. The bearing of P from Q. So it's going to be, remember they're asking you from Q, so we have to start at Q. And as we know, when we're dealing with bearings, we have to start from the north line going all the way around to where our P line is. So that's going to be the value from here all the way around to here. Yeah. To find this value, we already know our W is 77 degrees. So to find our bearing of P from Q, we can add 180 plus 77 plus 56, which would give us our value here, or we know the angles in a complete circle is 360 degrees. The angles around a point, 360 degrees. Since we know this angle here, we can subtract that angle from 360 degrees, and it's going to give us our answer. So we're going to have our first method. We can have 180 degrees plus 77 plus that's 0.77. Okay. One other thing, when we're dealing with bearings, you write it in terms of 3 units, 3 angles, yeah? Anyways, back to our question. So that's 77 degrees plus 56 degrees, and then adding this up, we're gonna have 180 plus 77 plus 56, which gives us 313 degrees. And then using our second method, which is 360 minus 47 degrees, we're gonna have 360 minus 47 gives us 313 as well, so we are correct. Obviously, in the exam, you only need to use one of these formulas. You don't need to do it both. It's only 1 mark. So either of these methods would give you your 1 mark. Now we're asked to calculate the distance RP, which is here. So I'm going to label this Q, small q. We need to find that distance, RP. In order to find that distance, we have a side, we have an angle, and we have another side, and we have an angle in between, and we're trying to find for this angle opposite to the angle that we know. So we can use the cosine rule. And our cosine rule is our small q, which is what we're trying to find for, our small q. Q squared is equal to, we're going to label this R and we're going to label this P. That is the first thing we should have done. So label our triangle. We have q square is equal to r square plus p square. And then we're going to subtract that from 2 rp. And then we're going to cos or angle capital Q. So whatever it is you're finding for, that angle is what we're going to be cosing. So that's capital Q. When working this out, I would recommend you work it out in sections. So it's going to be this section. So our two numbers squared added together. We're going to leave our sign alone. And we're going to work out this section here. Yeah, and we're going to work this out by itself as well. So rewriting our q square, we're going to have r square, which is 210 square, plus p square, which is 290 square, minus 2 times rp, 2 times 110 plus, multiply, sorry, p, which is 290, cos q, which is 56 degrees. Simplifying this, we're going to have q square is equal to 210 squared plus 290 square, which gives us 128,200. And then that is subtracted from 2 multiplied by 210 multiplied by 290, and then cos 56 degrees, which gives us 68,109 points. I like to write all of my decimal places just so that my final answer can be as accurate as possible. So 69564. Now we're going to subtract our two values, which gives us now 128,200 subtract 68,109.69564. And then that's going to give us a value of 60,090.30436, and that is what q square is equal to. Since we're trying to find for q, we need to get rid of our square, so therefore we're going to square root each side of our equation. So q is now equal to the square root of 60,090.30436. So if I pop that into the calculated square root, this is our answer, right? So if I keep this answer in my calculator, instead of having to rewrite this back, I can just put square root and click on this option here, which is answer, and that's gonna put the last answer that I had in my calculator, which is that 60,000 number, and then I click equal, and I have my answer has 245. Q is equal to 245.133238. It does not state whether to put it to the nearest decimal point, so I'll just write my answer to 2 decimal places. You could round it just to 3 significant figures, but I'll write it to 2 decimal places. 245.13 kilometers. Don't forget 3 units, okay? So that is how we find our distance of q, or the distance in a triangle that is not a triangle, a right angle triangle. We either use cosine or sine rule, dependent on what type of or what values we're given. Yeah. In this case, we use the cosine rule. We're finally on to the last question, which is question number 10a, and it says the transformation M is equal to 0p q0 maps the point R onto R dash as shown in the diagram below. Okay. And we're asked to determine the values of P and Q. Okay, so to determine the values of P and Q, we need to multiply our transformation M by our column vectors, which is going to be our column vectors of R, which is 2, -5, and for R dash is going to be 5, 2. Our transformation M, we have 0, P, Q, 0, and then that is multiplied by our column vector of R, which is our X is 2 and our Y is 5, 2, 5, and that gives us, because our R is mapped onto R dash, that is equal to our R dash value, which is 5x and then 2y. 5, 2. So we need to multiply out our M, or transformation, to our R. We need to multiply those two values, and then that value is going to equal to our R dash, and then we can simplify further. Multiplying our matrix here, M by R. Remember, when we're multiplying a matrix, it's going to be a row multiplied by a column. So that's how we multiply 2 by 2 matrix to a 1 column matrix. So we're going to have first row, so that's 0 multiplied by 2, which is going to give us 0, and then we're going to have 5, -5 that is, -5 multiplied by P, which gives us -5P, and then we're going to have Q multiplied by 2, which gives us 2Q, and then 0 multiplied by -5 gives us 0. And if we're to simplify this, we're going to have 0. We need to add these two values in order to get our 1 column vector matrix. 0 plus -5p is going to equal to -5p, and then 2q plus 0 is going to equal to 2q. Now that we've multiplied this, this is now going to be equal to our R dash value, which is 5, 2. This now means that -5p is equal to 5 and 2q is equal to 2. Now if we want to find the value for P and Q, then we need to make P and Q the subject of the formula. So if we have -5p is equal to 5, and we have 2q is equal to 2, to find the value of P here, it's going to be P is equal to 5 divided by -5, which would give us a P value of -1. And if we're to find the value of Q here, it's going to be Q is equal to, since this is multiplied, it's going to be dividing, it's going to be 2 divided by 2, which gives us Q is equal to 1. So that is how we find our values for P and our value for Q. We're now asked to describe fully the transformation M. So looking at our transformation, our point R mapped onto R, We can tell there was a rotation along the origin. Yeah, so that's one thing we can say. Rotation at origin with the coordinate 0, 0. And then we can also tell that there was a 90-degree rotation. But looking at it, remember we have clockwise and we have anti-clockwise. So this anti and this is clockwise. Looking at our rotation, our R to R dash, that was an anti-clockwise rotation. So it was a 90-degree anti-clockwise so that's anti and that's our clockwise. So we have 90-degree anti-clockwise rotation. Yeah, so that's how we describe our transformation.
Part B. PQRS is a parallelogram in which PQ is equal to U and vector PS is equal to phi. M is a point on QS such that QM to MS is equal to a 1:2 ratio. We have our diagram here. It says, write in terms of U and V an expression for vector QS, which is from Q here to here. Looking at our diagram, we see we have a QRS and QPS. Those are the two directions we can go. So I'm going to go from QR to RS. And that's going to be a phi. And then since I'm going in the opposite direction of the U, it's going to be minus U. My final answer is going to be V minus U. Part B, we're asked to write an expression for vector QM. Once again, QM is, from the information the question gives us, it says QM to MS is a 1:2 ratio. So 1 plus 2 is equal to 3. That means it's divided into 3 parts. So QM is 1 part and M to S is 2 parts in total. So halfway between is going to be 1 part. So looking at our question again, we're trying to find for QM to QS, that's like a third of our QS, which is V minus U. And that is going to be our answer for vector QM. Or we could write V over 3 minus U over 3. In the next part of the question says show that vector MR is equal to a third U plus 2V. So we need to prove or show that MR is equal to that. Looking at our diagram, we're trying to get from M all the way to R. So M to Q to R. To do that, we'll need to split up our vector. We can find how much or distance from M to Q and then from Q to R. My vector M to Q plus my vector QR. adding those together is going to give me my vector MR. Vector MQ, we found vector QM before, so vector MQ is the opposite direction. So therefore it's going to be minus vector QM. So if we write that, we're going to have minus vector QM and vector QM was minus a third V minus U. Or we could write it as V over 3 minus U over 3. And since our negative is multiplying everything in the bracket, we'll have minus V over 3 minus plus, so minus and a minus gives us a positive, so plus U over 3. And then we're going to add our vector QR, which is QR is the same as PS, which is phi. Therefore, vector QR is going to be phi. So we're going to add our phi at the bottom. And since we're trying to make all of this equivalent, we have 2 phi. So to simplify this, I would like to make all of my denominators the same. And my v currently has a denominator of 1. So I'm going to find the common denominator between that. So I'm going to write my over 1. And in order to make this common, all of these denominators common, I'll need to multiply my v over 1 by 3. So I'm going to have v minus v over 3 plus u over 3 plus 3v over 3. Now to simplify these two v's, I'm going to have 3 over v over 3 minus v over 3 plus u over 3. 3v minus 1v gives me 2v over 3 plus u over 3. And since I wanted this in the form of a third and then brackets u plus 2v, I can take my fraction of a third out, which is common in both of those fractions. So I'll have a third 2v plus u. And since technically u comes before v in the alphabet, I can rewrite this as a third bracket u plus 2v. And if I'm to multiply a third by everything in the bracket, 2v plus u, I'll get back my initial equation, which is 2v over 3 plus u over 3. Then finally, it said T is the midpoint of PQ. Prove that R, M, and T are collinear. So in order to find T is midpoint of PQ, which is here. And they want us to find that TMR are collinear, which means they're on the same line. They're all lined up nice and a straight line. So in order to find that, we need to ensure that they all have the same scalar factor. So I can use two vectors from this. So I can use RM, RT, TM, MT. Two of these vectors and these two vectors need to have the same scalar factor. So I'm going to use vector Tm and vector Mr. I already have vector Mr, so I don't have to do a lot of calculations there. But I'll have to find for Tm. I have my m common in both of these, and that is an important factor to ensure that my points are all on the same line. Okay, any two vectors you can use, but we have to ensure that our vectors cross the same point. So vector t to m is t to q and then q to m. So we already know pq is u. So t is going to be half of pq. And then we can find qm, which we've already found before. So vector tm is equal to half of pq and also we need to get from q to m. So we calculated vector qm before, which was a third v minus u, or v over 3 minus u over 3. So I can add that to my vector. So add vector qm. So simplifying this, I'll have half u, which is the pq value, plus my qm, vector qm value, which is v over 3 minus u over 3. There we go. Now I can simplify this. I have two u's in my equation, so I can simplify this. I'll try to make all of my denominators the same so I can simplify this. So the easiest way to simplify this is to multiply my 2 by 3, which will give me a common factor of 6. And my 3 multiplied by 2 . So I'll have 2u over 6 plus, multiply by 3. So that's 3u over 6 plus 2v over 3. Take away 2u over 3. Over 6, sorry. So all of our denominators are now the same. So I can subtract my 3u, take away my 2u, which leaves me with 1u over 6 plus 2v over 6. And I'm going to leave this like this just for now, okay? I want to show you something. All of my denominators are the same, all right? So I can see all of my numerators. I can take out my 1/6 outside of the bracket, and I can have 1/6 bracket u plus 2v. My 2v could have been simplified, but I'll leave it this way just to prove a point, okay? And my vector mr where were we? Vector mr is a third bracket u plus 2v. If we have a look here, we can see that our brackets are exactly the same. The things inside of our brackets are exactly the same. That means that these are the factors of each other. If I'm to take a 6 and multiply by 2, it would give me a third. So therefore, simply put, I can say mr, vector mr, is equal to 2 times vector tm. So if I'm to prove this point, if I'm to take my 1/6 and I multiply this by a 2, I will have a third. So 2 times 1 gives me 2. 6 simplified gives me a third. which is exactly the same as my vector MR. So this is one approach that we can use to prove whether our 3 points are collinear or they're on the same straight line or parallel, whichever phrase you want to use. This is just one approach. There's many other approaches that you can use to solve this question, but it is 3 marks, so you need to take your time so you don't get confused with your values. But remember, when you're choosing your 2 points or your vectors, you need to ensure that your vectors are going through the same point, one of the same points. So in my case, M was my common point, vector Tm, the vector Mr. I could have choose vector Tm to vector Tr, for example. So T would have been my common point. So it doesn't matter which 2 vectors you choose, just need to ensure that the 2 vectors include a common point.